Today we're going to do a related rates problem. Our problem states that a street light is mounted at the top of a 15 feet tall pole. Now, a man is 6 feet tall, and he's walking away from that pole with a speed of 5 feet per second along a straight path. So we want to know, how fast is the tip of the shadow moving when he's 40 feet from the pole? So the first thing that I've done here is I've already sort of set up the sort of basic structure of what we're doing, because otherwise that would have taken too long. But the first thing I want to do is remind you of the mnemonic device that helps us with related rate problems, which is DREADS up here, right? It stands for diagram, rates, equations, derivative, and simplify specific amounts, which is just S for simplify. Well, so the first thing that we're going to do is we're going to complete our diagram, right? Then we're going to figure out what rates we have, what rates we need. We're going to figure out what equation we can use. We're going to take the derivative of it to find the rate we're looking for, because that's usually how these work. And then we're going to simplify and get our solution. So the first thing that we're going to do is we're going to complete this diagram. And so let's read the problems. We know that the street light is the highest point, and that's 15 feet. So that's going to be this, right? That's going to be this side right here. And this is the lamppost. This is the lamppost. It's shining with red light, apparently. Okay, so what else do we know? We know that that there's a man standing 6 feet away, and that there is a man standing 40 feet away, and he is 6 feet tall. What does that tell us? Well, this is the man. This is going to be the man 40 feet away. He's going to be 6 feet tall. 6 feet tall. Well, okay. So he's 40 feet away, right? Well, that means that this length right here is 40 feet. Well, I'm going to say that length right here, I wrote it down underneath, is y. And that y equals 40 feet. Y equals 40 feet. Okay, so we know a couple things already. We know that we do not know how far away the man is from the tip of his shadow, right? Which is right here. This is the tip of the shadow. Tip of the shadow. And I guess maybe I should draw like a man so we know what we're doing. But, that'll do. Okay, so do we have anything else? Yes, we have one more given thing. Now that won't figure, I guess it'll figure into the diagram. We don't know this entire length here, okay? But we do know that we need to name it something for our equation later, and I've named it Z here. I've named our unknown distance X. And I have named this chunk that we know Y. Well, we know one more thing. We know that he's walking away at a rate of 5 feet per second. Now, he's walking away at 5 feet per second, and that's from here to here. So that is the change in Y over the change in time, which means that we know that dy by dt is 5 feet per second. And we say that like this, right? That is it's like the derivative sign. So we know that, and that's going to matter. We're going to need that for our equation later. What we also need to find out now, because now we're at rates, right? We've kind of done our diagram. We've kind of merged it with the rates part of the mnemonic device. Now we're going to look at our rates, and what that really means is that we're going to look at like what we need to find. We have this rate. We have the change in y over the change in time, right? Feet is the distance. Time is the seconds. So what do we need to find? Well, this says, how fast is the tip of the shadow moving when he's 40 feet away from the pole? Well, he's 40 feet away from the pole right now. So how fast is the tip of his shadow right here moving? Well, for that, we need the change in this entire length over the change in time, which means that what we're trying to find is the change in z over the change in time, dz by dt. Now note that there's a variable mismatch here, so we are going to need to apply the chain rule later on. But we're not there yet, right? Now it's time to find an equation. Now that may look a little difficult. When I first did this, I had forgotten, because we're going to apply something that, I don't know, it's probably 8th grade that you learned this in. We know that there's a right triangle here, right? There's a right triangle here, and there's a right triangle here. This right triangle is within the greater right triangle. And that means that we know that this side here, x, divided by this, so that the, well, we're not using angles here, but that this side here, x, let's call it the base x, divided by the height, 6, equals the base z divided by the height, 15 feet. And that's going to be our equation. We're going to rewrite it, but that's going to be our equation. It's going to be x over 6 equals z, or z, over 15, depending on where you come from. I say z, but that's because my alphabet, my original language, it sounds more like z. So now we're going to want to simplify that. I guess I should probably write the entire simplification out. I mean, probably. Let me just take a little box here so we don't get all confused about what's happening. Okay. And we're just going to simplify this. We're going to write, first of all, what do we need to do to simplify this? Because we don't know what z is, right? But we do know that z is x plus y. And we know what y is. So let's rewrite it, right? We know that z equals x plus y. And therefore, x equals z minus y. X equals z minus y. Oh, sorry. I didn't mean that we don't know what z is. Because we don't know what z is, but we're going to be solving for the rate. So we want everything in terms of z, because that's the rate we're looking for. I actually meant we don't know what x is, so we want to get rid of x. We want it both to be in terms of z. But we know that x is z minus y, and we know what y is, so we could just use that instead. So we're actually going to have z minus y over 6 equals z over 15. And I don't really feel like doing all the algebra here in the video right now. It's not really an algebra video. What it's going to simplify to is 15y equals 9z. I'll do one step. 15y equals 9z. And then what that's going to simplify to is, well, I should do the implicit differentiation, actually. Sorry. I definitely should. That is what our equation is going to be, right, in the end. But now, this is actually very important. I don't have no idea why I was going to skip over that. It's like the main point. What we're going to do is we're going to take this equation right here, okay? Let me take this side so it doesn't look like we're merging work. Okay. We're going to take this equation, 15y equals 9z, okay? We know y is 40, but we're not going to use that yet. Well, what do we do with something like this when we're trying to get the rate of z? We're going to take the derivative of both sides, which is called implicit differentiation, and related rates problems are just implicit differentiation problems, but word problems, right? So we're going to take the derivative of both sides, which means we are going to get, and we're going to pull out the constants, right? So we're going to get 15 dy by dt equals 9 dz by dt. Change in z over change in time, change in y over change in time. Well, variable mismatch on both of these, which should tell you that we're going to use the chain rule, like I kind of mentioned in the beginning. Well, and that's okay, because when we use the chain rule on dy by dt, we're gonna be able to use the rate we already have. We're just gonna have one unknown, and we're gonna isolate that and solve for it, right? So what we're gonna end up with over here is 15 times 5 feet per second, because we know that dy by dt is 5 feet per second. We don't really have to differentiate that. I mean, we could, but we would still be plugging it in, so it's kind of silly. And then on the right, we're going to end up with 9 dz by dt. Hold on a minute. What am I doing wrong? Oh, we aren't going to have a chain rule. We actually aren't going to have a chain rule, because It's not z squared. See, if it was z squared and we'd have to like apply different, like we'd have to differentiate it before we could isolate dz by dt, then we would use the chain rule. But because it's just dz by dt and that's what we're solving for, we don't have to use the chain rule at all. So ignore what I formerly said and just watch what I'm doing instead, which is that this is already what we want, right? We want to solve for this. Solve for this. So we're going to just divide by 9. We're going to end up with dz by dt equals 15 times 5 over 9, which equals 75 over 9, which if we simplify it, we'll simplify to 25 over 3. And let's not forget our units are feet per second. And that is our solution. So if you want to write a sentence, because you usually, it's depends on the professor or teacher. In high school, all my teachers always wanted me to write like a full sentence explaining my solution when we had word problems. But my professor in Calculus 1 does not want that. So it depends. But if you wanted to do that, what you would say is the tip of the shadow when the man is 40 feet away from the pole is 25 over 3 feet per second. So that's the rate. He's moving away at a rate of 25 over 3 feet per second. That's what you would say. And that's our solution, and I hope that this was helpful.